Hello, welcome to the encode and decode presentation part 2. The demonstration of the functionality now continues. The next thing I'm going to show you is how you can use $encode and a hashing algorithm to verify a file download. I'll start the form up called demo, and I'll show you how it works before I show you the proc code to enable this functionality. So we'll start testing the component, and imagine a situation where you've gone to a website and you've downloaded a particular file, but you need absolute verification and proof that you've got the file downloaded without corruption. The easiest way to do this is to take advantage of the published checksum and compare it with your downloaded files version of the checksum. So bear in mind here that the SHA1 algorithm was used, and that's the checksum that we'll be looking at later on. So we go over here and choose SHA1. We browse to the file. I happen to have downloaded this file previously to my desktop, so I can select it here, open it, and we immediately have an output value. The file integrity check button has proc code to actually do the encoding immediately. If I restore this browser window, you could then pause this video if you wish and verify that what Uniface has calculated is the same as the published checksum on the website. Now I'm going to demonstrate a more traditional cycle of encoding and decoding texts and data in general. For this purpose, I'm going to choose the Blowfish algorithm. I will leave the default mode of ECB, and I'll type in some simple text. Now, I have to supply a key so they can be decoded later on as well. And in this case, say I can't remember how long the key should be, you can refer to Uniface library for some help under $encode, and amongst the values that are there, you'll see that there's a table of required key lengths and block sizes. For Blowfish, you have to supply a key that is between 1 and 56 bytes long. That's very straightforward. So I'm just going to type in 1, 2, 3, 4, 5, 6. Press the encode button to create an output. This out field contains a hex modified version of the actual encrypted key, encrypted string I should say. So if we want to then prove that we can decipher this as well, I will cut this out of that field and replace it as an input. Now suppose we didn't get the key right and we try to decode it. Note that we have a message that's been trapped in $proc error message. Notice there's an error of -1791 there. What does that mean? Once again, we can go to Uniface library, go to $decode, look at the message, and we see that -1791 is just a general encode decode error. What that means is there's no actual proc or Uniface errors here. It's simply that the encoding decoding didn't work, and that's what we expect because the key is incorrect. So let's supply the correct key. And we can see that the original message has been faithfully restored. So let's see how this is actually done in proc code. First of all, let's have a look at the file checking button. We can see here a declaration of some raw variables. The first statement is a filebox statement, which allowed me to select the file name from my desktop and it returns that in $result. Thus, when we do a file load /raw of that file, we give the results into the in_raw variable. We take the contents of that file and then pass this through $encode, and we get an output in raw variables, and the raw variable is then converted to hex so that we can display it in the out field. Next, let's look at the encoding trigger. The coding here is more verbose than you might expect, but this is because it is capable of handling all the various input parameters required for $encode. As you may recall from part 1, the actual parameters required for $encode are dependent on the algorithm chosen. You can see, for instance, here that some of the encoding methods require an initialization vector. You may recall I chose ECB, so it didn't actually need this, but if it did, then it would have calculated it based on a date timestamp from $DATIM. Whatever algorithm's chosen and syntax is required to build up the transformation, it comes down to this statement here. The initialization variable is available, the mode that's chosen from a drop-down list is available, the key that I typed in is available, the input string to be encrypted, and of course the chosen algorithm from the drop-down list as well. This is all then encoded and put into the out raw variable. To be able to then display the results, we take out raw and encode it in hex so that we can see the results. If we look at the decode trigger, detail trigger, we of course bear in mind that once again there is a little bit of testing in the code to determine what the right parameters the $decode should be. Basically, you should also recall that this example is displaying the encrypted strings as hex, so we have to first of all convert the hex string into a raw string so that the $decode can work properly. So there's the first step, and there's the second step. Take that raw input, run it through the algorithm, and to get an output raw field. We take that and then further convert it into a string for the out parameter for display. That's all that's required to make use of $encode and decode, and as usual, refer to the Uniface library for further documentation. Thank you.